Alright guys, so here's going to be your notes for solving trigonometric equations. You could follow along. I posted the PDF of the notes that I'm showing you with the example problems. I posted it in the material on Google Classroom. So you'll be able to find it. You can follow it along and you can copy it down or print it out or whatever you need to do. So I have some of the examples already done and I'll go over them and then some we'll do together. Let's talk about strategies first. So you always want to use some algebra techniques, to get the trig by itself. So add, subtract, multiply, divide. You're doing that by numbers, not by the trig functions. So you always kind of want to leave them where they are. If you do have multiple terms, you do want to get them on one side, and we'll do an example like that. You could factor. You could use a quadratic formula. I'm going to show you that one. Square root both sides. Really whatever you need to do to solve each question. So we know that once we get that down to either just a sine of x equals something or cosine or tangent, you can kind of undo it by using the inverse trig function on your calculator. So that's one method, is once you get the sine or cosine, whatever it is, down to just singular by itself, you can do sine to the -1 to kind of undo it. You could also use your unit circle. So you're going to see that for most of the ones that we're going to be doing together, the values will work out perfectly for your unit circle. So there is one attached on one of the last pages of this PDF, or just Google unit circle. Okay, so let's look at some examples. Let's start slow here. So our first example is where we have 2 sine of x equals 1. And they're asking us just for the angle measures on the interval between 0 and 2 pi. So we can give just nice definite answers from our unit circle. So you can see here that when you have 2 sine of x equals 1, you can divide by 2. And now it's telling us that sine of x is 1/2. So using your unit circle, you just find whatever values will give you your sine value of 1/2. So you can either do that by using your unit circle and seeing that it's pi over 6 or 5 pi over 6. Or you could plug it into your calculator. So if you were to plug this one into your calculator, you would do sine to the -1 of both sides. And we've done this, so this should look a little bit familiar. When you do that, you just have to remember what mode your calculator's in. If you want it in degrees, your calculator needs to be in degrees. I would suggest definitely degrees, because you're never going to see some sort of like pi over a number as your result. So you get x equal, and when you would plug it in, it probably will only give you 1. Okay, so that's why you want to make sure that you're confident with your unit circle as well. So let's do the second example together. So we have our cosine of 2x plus the square root of 3 equals negative cosine of 2x. So this was one of those situations where we do have, trig on both sides, but we want to get them combined. They are considered like a like term because it's the same function, same what's on the inside, the 2x. So we're going to get them together. So we have cosine of 2x plus the square root of 3 equals negative cosine of 2x. So we can get them all on one side. So we have square root of 3 equals -2 cosine of 2x. You can treat them like variables. So if you have cosine of 2x and a negative cosine of 2x, when you subtract, now you have -2 cosine of 2x. We're going to divide by our -2. So now we have -√3/2 equals the cosine of 2x. So we do have values where the cosine is -√3/2. When we're breaking this up, we need to make sure that we keep in mind that this is a 2x over here. So when you break it up, it's not just going to be x equals and whatever we find, it's going to be 2x equals what we find. So using a unit circle, we're going to find which endpoints would end up with a -√3/2 for cosine, which we know is our x value on the unit circle. So the two values that you would get, or actually we would get 4 here. No, we get 2. We would have 5 pi over 6. And remember, we're going to set that equal to 2x. And then we also have 7 pi over 6. Also equal to 2x. So this one we do have a step further we need to take, which is divide both sides by 2. So we end up with 5 pi over 12 to equal x. And then we also get 7 pi over 12 to equal x. Okay, and if you were doing these in degrees, it'd be 75 degrees and 105 degrees. Okay, so once you did that, you could even do that in the calculator as well, but remember in the end you still need to divide your result by 2. So your two answers would be the 5 pi over 12 and the 7 pi over 12. So let's look at another example that's already completed. So this one's a little bit different because now our trig function is squared. So when you're looking at this, we see that we do need to add 1 first and divide by 3, so that should make sense. It's a little bit of algebra. Then we have this cotangent squared. So just like with algebra, you can square root, and when you do, it'll get rid of the square. So we end up with cotangent of x equals plus or minus 1 over root 3. And then we know that if we were to flip cotangent over, the reciprocal is tangent. So we could do the same thing to both sides of this equation. So when you flip your cotangent over, you get tangent. When you flip your plus or minus 1 over root 3 over, you just get plus or minus root 3. So now you're looking on your unit circle for all of the times that your tangent value equals plus or minus root 3. So I listed the 4 values that this would occur. So again, looking at your unit circle, you don't see tangent, but you do see sine and cosine, which is how you would find tangent. And so these are all the specific values where it equals root plus or minus root 3. Now, our specific question up here is asking for all values of x. So we know that any angle that is coterminal will also have the same value. So we know one full loop around is 2 pi. That's 360 degrees or one full rotation on your unit circle. So if you just keep making your loops around, keep adding 2 pi, you're good to go. So you can just add 2n pi, because that way it covers all your bases for however many rotations you're working on. So let's use that same idea for all values for the next example that we'll do together. So this one has a little bit of factoring as well. So I told you we'll see one where we could do a little bit of factoring. So the first thing that we need to think about is we know we need to factor and not add the 1 is because this sign is squared and this is sine to the first power. So you can kind of imagine this like if sine was just x, right? You would have 2x squared minus x minus 1. And you could factor that. You can use your a times c method. You can use any other method that you have, but a times c is probably the easiest. And we're going to factor. So to factor that, we would get 2 sine of x plus 1 times sine of x minus 1 equals 0. So to get to that point, we factored. If you wanted to see the work on how to factor that, just pretend sine's a different variable. So if you wanted to pretend that sine was just s. So if you had 2s squared minus s minus 1 equals 0, you could do your a times c method and you do 2 times negative 1. You get negative 2. You know 1 and 2 are the only factors. So when you get that set up, you have 2s squared. And now we need to somehow combine 1 and 2 to get negative 1. So it'd be minus 2s plus s minus 1. Group your terms. So you could take out a 2s and you're left with s minus 1. You could take out a plus 1 and you're left with s minus 1. And you have your 2s plus 1 times s minus 1. And if you look at what we have above in red, that's what we have there, except instead of s, now we have sine. That's what we kind of use as shorthand for sine. Okay, so once that's factored, I'm just going to continue below. So once it's factored, you could set both factors equal to 0. So you have 2 sine of x plus 1 and sine of x minus 1, and solve them both. So you have 2 sine of x to equal 1. This looks like our first example we did together. Sine of x equals 1/2. Over here we have sine of x. Oops, that was plus, that's minus, that's negative 1/2. And then over here we have a plus 1. So then we're trying to find our x values that equal 1. So for our negative 1/2, we have x equals 7 pi over 6, 11 pi over 6. Those are the only values that would give us negative 1/2 specifically, but this one again was asking for all values. So we could take both of those and add 2n pi. So we're just going to keep finding the next coterminal angle. And then over here, when x equals 1, you get x to equal pi over 2. That's the only value, but we're asking for all values. So again, add that coterminal, so add 2n pi. So here's another example worked out. Pretty straightforward. I'll let you look at that for a second. Always remember you can pause, go back, write this down, whatever you need to do. And there's one more that I wanted to show you, and that was number 9 on this page. There's a lot of practice problems for you to work on, but just to show you again that this would be one of those factoring ones. You wouldn't want to add 5 first. You would want to factor because you have basically you have your sine squared, sine to the first, no sine. So it's the same rules that we have for when we're trying to factor just a quadratic function. So when you're trying to work on this, we know that it would be binomials being multiplied. And you want to figure out what values are going to multiply. Where are we at? Multiply to give you your -5 and combine to give you -4. We also need to make sure that our two first values are sine. So you would have sine of x, and then we know that we need them to multiply to -5, add to -4. So if you do a -5 and a +1, that'll all work out. And then you could set both factors equal to 0 and solve from there.